Have you ever stopped to think about the invisible rules that are running basically everything? For the longest time, people thought that the way planets moved and the way a ball flew through the air were two totally separate things. But then Sir Isaac Newton came along and showed us that it all comes down to the same three beautiful, simple principles.
We've all been there, right? You're in a car, it stops suddenly, and your whole body lurches forward. That feeling? It's not just some random sensation. It is physics, live and in person. And it's the perfect way to start understanding Newton's legendary three laws of motion. So, let's start with law number 1, which I like to call the lazy law. It's a great name for it because honestly, it's about how objects just kind of want to keep doing whatever it is they're already doing.
Okay, so the official name is the law of inertia. Sounds a little intimidating, but the idea couldn't be simpler. Things just don't like to change. If something is sitting still, it wants to stay sitting still. If something is moving, it wants to keep moving at the exact same speed and in the exact same direction.
This is the human version, right? It just makes so much sense when you put it that way. Objects are lazy. In that car example, your body is moving along with the car. When the car stops, your lazy body wants to keep right on going forward. That lurch, that's inertia. And this shows both sides of inertia perfectly. Think about a soccer ball on the grass. It's just going to sit there until an outside force, your foot, comes along and kicks it. But once it's moving, why doesn't it go on forever? Well, because other forces jump in. You've got friction from the grass, you've got gravity, they're working against it. But if you were in deep space, yeah, it would just keep going and going.
Okay, so if inertia is all about things resisting change, how do we actually make them change? How do we get things moving? Well, that leads us right to law number 2, the big push.
Now this one has a little bit of math, but don't worry, the idea is totally intuitive. You've probably seen the equation F equals m times a. All that's really saying is that how fast something speeds up, its acceleration, depends on just two things, how hard you push it and how much stuff, or mass, it has.
And let's be real, we all know this in our bones. It's super easy to toss a baseball, but it's a lot harder to throw a bowling ball, right? Why? The bowling ball has way more mass, so you need a much bigger push, a lot more force to get it moving.
Imagine this. You're at the supermarket and you give an empty shopping cart a good shove. Whoosh! It goes flying down the aisle. Now picture using that exact same shove on a giant semi-truck. Yeah, that truck's not going anywhere. Same force, but the massive difference in mass means you get a very, very different result.
So here's the key takeaway. Force and acceleration, they're basically best friends. You add more force, you get more acceleration. It's a direct link. But mass is the one that slows the whole party down. The more mass something has, the more force you're going to need to get it to accelerate.
All right, so objects resist change, and we need force to make them change. But there's one last incredible piece to this puzzle. See, forces never work alone. They always come in pairs. Which brings us to law number 3, the pushback.
This might be the most famous law of them all, and it's so elegant. For every single action, every push, every pull in the entire universe, there is an equal and opposite reaction. It's a perfect balance.
Here's a simple way to think about it. When you lean against a wall, you are pushing on that wall. But what stops you from just falling right through it? The wall is pushing back on you with the exact same amount of force. You literally can't touch anything without it touching you back.
A rocket launch is the ultimate example of this. It's so cool. The action is the engine blasting hot gas down towards the ground with incredible force. The reaction is that gas pushing back up on the rocket with an equal and opposite force. And that's what sends it flying into space. Okay, hold on. This is a great question, and it's where a lot of people get tripped up. I mean, if the push down is the same as the push up, shouldn't it all just be a tie? How does anything go anywhere? It feels like it should all just cancel out, right?
And here is the secret. They don't cancel out because the forces are acting on two different objects. The rocket pushes on the gas, and the gas pushes on the rocket. Since they're acting on separate things, they can't cancel each other out. One force makes the rocket go up, and the other force makes the gas go down.
So there you go, 3 laws. They might seem a little abstract, but they are woven into the fabric of our reality. They govern every single thing you do, every single day.
And this was Newton's real stroke of genius. He realized that the same law of inertia that keeps a planet locked in its orbit is the exact same law that makes you stumble when you trip over a rug. The law that launches rockets is the same one you use to push a cart. It's all connected.
So let's just boil it all down one last time. Law number 1, objects are lazy. They want to keep doing what they're doing. Law number 2, heavy things need a bigger push to get them going. And law number 3, you can't touch anything without it touching you back.
So the next time you take a step, or you throw a ball, or you feel that lurch in your car, just take a second. Appreciate that invisible, elegant dance of forces that's happening all around you. You're not just living your life. You are a living, breathing example of the fundamental laws of the entire universe.